can't remember. Oh, good. When I made this for you, I included my little story at the bottom. Yeah. How did you do with the number 5? Did you like it? Yeah, you did. I'd say you loved it. Did you like number 5? Right. Okay, let's start. The first one, a small 100 microfarads connected to a 150, and then it's charged. What's the total capacitance? Right, well, in this case, in number 1 here, it's in series. So how do they add? 1 over, isn't it? So 1 over 100 plus 1 over 150. What's that? That's 3 over 300 plus 2 over 300, which is 5 over 300. But for C, that would be 300 over 5, which is 60 microfarads. I really hope you got that. Okay, B. A small capacitor is charged with 50 is connected in parallel with 200 and 6 volts is used. What's the total charge? Okay, so Q is a half CV squared. That's a half. Now what's the C here? It'll be 200 plus 250, right? So that's 250 times 10 to the minus 6. And the voltage squared, 36. Yeah? Problem? I'm sorry. No, stop. Forgiveness, please. That was the energy. Q equals CV. Thank you. Which is 250 times 10 to the minus 6 times 6. Yeah? Yeah. That's 1500 times 10 to the minus 6 coulombs. So 1, 2, 3, 1.5 millicoulombs. Yeah, well, if I change 10 to the minus 6 in my head to 10 minus 3, 10 minus 3. Huh? Is this not the same as this? Do you not think?
10 minus 9.
1500 microcoulombs. So if you do another 10 minus 3 becomes 9
Yeah.
Huh? 1500 times 10 to the minus 6. Are you happy with me saying that's 1500 times 10 to the minus 3 times 10 to the minus 3?
Yeah.
Agree or disagree?
Agree.
1500 times 10 to the minus 3, is that not 1.5?
No.
Isn't it?
Yeah.
And is 10 to the minus 3 not milli?
Yeah. What are you saying?
What are you saying?
Yeah, I was right. Okay, number 3. A 100 is charged in parallel with a 200, and then they're connected to a 300, although I didn't say how, but in series. Right, so basically you've got here a 100, here a 200, and here a 300. Yeah? So how much have you got here? If that's a 100 and a 200, then together? No, 100 and 200. 300. And this one here, I said is 300. So adding them together, 1 over 300 plus 1 over 300 is 2 over 300. So it means the C is 150.
Yeah.
I hate this question.
No.
What?
No. What? How much charge is held by each capacitor, and hence find the total charge held by all capacitors? First, I'll get the total charge. The total charge will be CV. What's the total voltage? 12. 150 times 10 to the minus 6 times 12. What's that, please? Some dudes with calculators?
1.8 milli.
Now, are we sure about this?
Yeah.
1.8 millicoulombs. Now, that's the total. But what about for each? So, do you remember the rules here? If it's in series, then it means that these two must be the same as the total. So this is 1.8 milli, and this is 1.8 millicoulombs. Now, what about when they're in parallel? They should add together, shouldn't they? To make a total of 1.8. Now the problem is, will it be 0.9 and 0.9? No, because they're not the same. This is a 100 micro, and this is a 200 micro. So what you could do is you could work it out by using this formula. Because we know the C. Huh?
Can we make ratio?
Well, this is what I'm getting at, yeah. You know the C, and you know the V. No, actually, that's not true. You don't know the V. You only know the V for the whole thing. You'd have to work it out. But if you're smart about it, like you were saying, because this capacitor is twice as big as this one, then logically it should hold twice as much charge. So we are looking for two numbers. One number that's twice as big as the other number, but together they make 1.8. Well, that has to be 0.6 and 1.2, because this is twice as big as that. They add to make 1.8, so it must be that. So we have 0.6 and 1.2 millicoulombs in the parallel capacitors and a 1.8 in the total. Did anybody get that? Did people get this? Yeah, good. Okay. 4. A 150 microfarad capacitor holds a charge of 150 millicoulombs. My vowels are really off today. I just said millicoulomb and kilocoulomb. Right. A 150 microfarad capacitor charged up to 150 millicoulombs. What is the voltage? Okay, so we have a few formulas. Q equals CV. So V equals Q over C. Actually, that's all right, because we know the Q, don't we?
Yeah.
And we know the C.
Yeah.
So that would be 150 times 10 to the minus 3 over 150 times 10 to the minus 6. So that's 1 kilovolt.
Yeah.
Kaboom. All right. Yeah. Big. 1 kilovolt. Okay. Now on to the nice question. 5. Yeah. Did anybody feel like they got 5?
4.
5. Let's do 5 now. Yes?
The order is different when working from what did you give us different papers?
I might have given you an updated page. I don't remember. I'm sorry, but what I will do for you, once I've typed up all the answers and put in the videos into the worksheet, I'll upload them onto Moodle, because I think the only ones I have on Moodle are the mechanics ones. I'll update the electricity and the materials. 5. A 200 microfarad capacitor is placed in parallel with a 300 one, and they're both fully charged up by using a 5-volt battery, as you can see in the first picture. Now, the battery is removed and the circuit is closed, as you can see in the second picture. Now, onto the third picture. The smaller capacitor is flipped around so that the current flows the other way from it. But the effect of that is to cancel some of the current from the bigger capacitor. So in effect it reduces the current. And what is left, we would like to know the voltage of what is left. Okay, let us see. So the very first thing I would like to do is work out the charge in each capacitor. So in the first one, Q small and Q large, that's 200 times 10 to the minus 6 times 5. 200 times 5 is 1,000. Is this 1 millicoulomb? Is that right? And the larger one is 300 times 10 to the minus 6 times 5. I think that's 1.5 millicoulomb. Yeah? Now, you have the capacitor. This guy has 1 millicoulomb. This guy has 1.5 millicoulombs. And when it discharges, that should come out in total making 2.5 millicoulombs. But that's not what happens. What I do is, instead, I flip this one around. The result is to reduce rather than to add, leaving me with only 0.5 millicoulombs. So now in my picture, what I have is this. I have two capacitors. This one is empty, basically, and this one is charged. And what has been released is only 0.5 millicoulombs. And I want to know what is the voltage that you get. So, this is going to go around and go back in here, and it's going to charge the capacitors back up. Now, in real life, this doesn't happen, because in real life, you know, there's resistance in the wire. So by the time the charge gets back around, you know, you're losing voltage, it's being reduced. But let's just imagine that everything is nice and clean and there's no resistance, which I know is not realistic, but for a short time it'll be realistic. It's only after a few seconds that this is running that the wires will heat up. So what will happen now? That 0.5 will re-enter the capacitors, causing them to charge both back up. What is the voltage? Well, we have Q equals CV. We know the Q and we know the C, so what's the V? So the V will be Q over C, which will be 0.5 times 10 to the minus 3. But what do we use for the C? Should we use both, or maybe we should just use the one that was charged up? Or we should use both, because they both will become charged back up. Yeah. Okay, so that is in parallel, making a total of 500 times 10 to the minus 6. So what is that? That's 1 times 10 to the minus 3 over 1,000 times 10 to the minus 6. That's 1 volt. Is that 1 volt? Mm-hmm. No, 1... yeah, 1 volt. Yeah. Did anybody get 1 volt? I made the answer easy. 1 volt. Yeah.
So the value for C is a fixed value, they will not change.
Yeah. Capacitor has a certain ability to hold charge, and this. In fact, we can actually change this. What determines its capacitance is how close the plates are together and their surface area. So by making the plates bigger and closer, we can increase the capacitance. In fact, if we can make a vacuum between the plates, we can increase it even more. So for us, we don't imagine capacitance changing. It's a fixed quantity for the capacitor. Okay, can I close this one now and go on to the next one?